parti? Okay. Hello everyone, thanks for coming to this session. So today we are going to talk about micro frontend. Quickly to introduce myself, my name is Audrey, I'm a full stack developer. I used to work for Saagie, but I'm not working anymore for them. So if you have questions about the company, I won't be able to answer. But I'll be able to answer about every question about micro frontend. To start, we're going to look through the evolution of our architecture. Applications architecture. And to do so, I thought it might be easier to take an example we all know about, the Java Petstore. I know you missed it, right? So when it was launched by Sun, something around 2005, any language it would have been written at this time, the Java Petstore would have been a classic end-to-end monolith. And then, you know, front-end development became a thing, and all of these fancy JavaScript framework that we all love appeared. And that's usually the moment when we splitted our monolith application into a front-end application and a back-end application. And then microservices entered the game. So that's the moment where we started to break our back-end application into a set of services, each one being in charge of a specific part of the application, and only one. An interesting thing to notice there is the way our team organization is strongly tied to our architecture. When we were just having a monolith, an end-to-end monolith, we usually just were one team, the Petshot team. And then with the split between front-end and back-end, we usually splitted our teams too. So we ended up with a front-end team and a back-end team, with one being the customer of the other one, but not necessarily working strongly together. For example, I used to be in the back-end team, and I was having two front-end teams working with me. One was in the office next door, the other one was in another city. Curiously, the one which was in another city was having less information than the one next door. So you begin to introduce some frictions there. And then, you know, with microservices, usually we are splitting the back-end team into smaller teams. One team per domain, per area of business, usually, or several, if they are small enough. So in the pet shop example, that would give us the product team, and the search team, and the checkout team, for example. And the good things with having a small team is that they are specialized. So they are doing just one thing, but they are doing it well. And usually they are delivering faster than bigger team. That's the first benefit of micro frontend. The second is that with microservices, you get a complete freedom in your stack choices, meaning that if the product team wants to work with Java and the search team wants to work with, I don't know, Scala, and the checkout team wants to work with Kotlin, it's not a problem at all. So each team can go for the stack, which is both the more comfortable to them and the more relevant to them. Plus, microservices are easier to deploy because when you get a new feature to deliver, you don't have to just redeploy, you know, the entire monolith. You're going to redeploy only the service which has been updated. And for the same reason, they are easier to scale because you usually know which services will be requested more. So you're scaling those, you're leaving the rest living this way, and it will work perfectly fine. So, if we're looking back at our front-end and microservices architecture, it looks like everything is finally optimized, completely, perfectly optimized at its place, etc. And actually, it's not. It's not for two reasons. The first one is that you now have a front-end monolith, which is just as hard to maintain and evolve than your back-end monolith was. And the second reason is that it's because so you're still having this, you know, customer relationship between the front-end team and back-end team, except that this time you're having one front-end team in front of smaller back-end teams, which are delivering faster. So you're introducing more frictions there. Considering this, it's time to move to the next step of our architecture evolution, which is obviously micro frontend. The core idea behind micro frontend is to consider the application as an aggregation of feature. So we are going to keep the idea of having small teams. We are going to keep our microservices on the back end, but we are going to split the front-end application, and we are going to split the front-end team. So now each domain will be, and each team will be in charge of its part of the feature from end to end. That's a classic way of working for e-commerce companies, but not only. Facebook is doing the same, Spotify is kind of doing the same, but in a very strange and particular way. Some of those companies are sharing the way they are doing it, some don't. I strongly recommend you to have a look at the way they are doing it when they do communicate about. So if we're looking back at our pet shop example, but nicely improved thanks to Antonio, it means that, for example, we would have this page which is maintained by the product team. And the product team is the only one to be in charge of this page. And the product team is going to use components provided by other teams. So here, for example, it's going to use the search component provided by the search team and the checkout menu provided by the checkout team. And another big idea behind Micro-Frontend is that each team should still be able to go for the stack which is the more comfortable or relevant to them. Which means that, for example, we could imagine having the product team working with Angular and the search team working with Vue and the checkout team working with React. So now we only have small and specialized team, but very important distinction, they are now customer focused. So they can simply, ignore what's going on in the rest of the application to focus on their part of the business to provide the best experience possible to the customer on their very own area of business. So for example, for the product team, it would be to present the product in a very clear way with, probably related product and accessories and all that kind of stuff. For the search team, it would be to provide a search experience which is rich and fast and simple. And the checkout team would probably try to provide a smooth and fast payment experience. So we're keeping the benefit of having small teams, but it's now customer-focused team. And we still have the freedom in our stack choices, but now extended to front-end, which is quite a big deal, right? Your team are more autonomous in their development process because they don't have to run the entire application on their laptop to develop just the part they're working on. They're going to work on their own component, and if something is broken on the product part, for example, it has no impact on the work of the search team. They will be more autonomous in the release of features too, because now they are taking charge of the release from end to end. You don't have to wait for the front-end team to integrate all these new APIs coming from the back-end micro teams. And finally, making your application evolving is made easier because when you plan to refactor a screen, for example, you don't have to do it in one way. You just simply plan it. You're going to make it component by component, and it will work perfectly. So now that we've seen the theory, which is always fantastic, let's move to a real-life study case, which is Data Fabric. That's the name of Saagie's product, and it all started with the manager, which is a kind of orchestrator for data scientists and data engineers where they can upload, run, pipeline all their data extraction and data processing jobs. It was launched in July 2015, so quite obviously, at this time, it was written in AngularJS. Then came the governance, which is the tool I've mostly been working on. This one is very different from the first one, because this one is for business people, for chief data officer, all these kind of business-related persons, to help them manage the data in their data lake. This one was released in March 2017, so it was written in Angular. AngularJS was already so 2015. And then a few months later, we delivered operations, which is completely different from the two others because this one is not tied to a data lake/platform. This one is an overall tool to enhance the customer experience. So basically, it's going to help the customer to monitor the health of every platform. And this one was written in Vue because we wanted to give a try to Vue. And at this point, we realized a few things. First of all, we knew that we had to refactor the manager for 2 reasons. The first one is that when the manager has been written, it was a classic monolith, backend and the frontend, but still 2 monoliths. And obviously, the manager was having the security modules inside its monolith. Problem is, governance was using the security module, and operations was using the security module. And okay, so we needed to extract the security part in its own application with perhaps its own front end. Second problem, the workflow of the manager was not corresponding to its user's workflow. So anyway, this part was needed to be refactored. Then we knew at this time that we were having the need for all the tools like operations to enhance the customer experience. And last but not least, all of those tools, new ones, but existing ones too, were needed to be displayed in the same page. That's where the fun began. So in October 2017, we started working on the version 2 of Data Fabric. And we decided to move to micro-frontend architecture and team organizations. So we splitted the 2 existing teams into smaller teams. And we made a few tries, because on the human side it went smoothly, but on the technical side it was a little bit more tricky. The first try was called Layout. It was released in December 2017, pure JavaScript. The second try was called Galaxy, released in 2018 in React. And the third try, which is in production since July last year, is Layout-as-Lib in JavaScript 2. And that's what we are going to talk about right now. So first of all, to give you an idea of what we were looking for this version 2, here is what we were targeted. So you got a primary nav menu on the left, which allows the user to navigate from a platform-related application to other platform-related applications. Then you get a top bar menu, which is going to let the user navigate from non-platform related applications, so security, operations, etc. Then you get a pretty classic user menu. And the main part of the page is the existing application. So it could be either the AngularJS, the Data Fabric application, or the Angular application in Angular, the governance application in Angular. And before we're going further into technical details, I would like to say a word about design system. Who knows about design system? No one? Well, yeah, 3 persons, pretty nice. Because there is no way to provide, to go for micro frontend if you're not going to provide a consistent user experience. So design system is kind of, it's a library of components with styles and behaviors. The Saagie one is called Saagie-ui. It's public on NPM. It can be reused for commercial purposes, but you can feel free to have a look at it, you know, just to get inspired. So let's move to the try number 1, Saagie-Layout. So Saagie-Layout is an aggregation of web components, as described on the site microfrontends.org. Don't worry about the links. I'll give you all of them at the end. So it's really like the architecture we've seen previously in the slides, but this time it's completely based on a web component, which means that we are going to take every component we've seen previously and encapsulate them in web components, and the main application will also be encapsulated into web component. So it could be either, yeah, still the AngularJS or the Angular application. Quickly to introduce web component, if you're not familiar with, it relies on 4 specifications, which can be used on their own, but combined together, allow the users to first define the custom elements, to define your own tag, which style is going to be encapsulated and isolated thanks to the shadow DOM. So very useful when you're as good in CSS as I am. With HTML templates that, it's markups of templates that can go use that page load but can be instantiated later. And thanks to the AS modules specification, which have a consistent way of being imported. So how do you declare a web component? That's pretty simple. You're going to declare a class which is going to extend the HTML element. And once you've done that, you get access to a set of API to manage the lifecycle of your component. First of all is the connected callback method, which is called every time the component is attached to the DOM. Then you get the disconnected callback method, which is called when the element is removed from the DOM. And then you get the attribute change callback method, which is called every time the value of an attribute has changed. So for example, if your component has an attribute called color, let's say, and the value is blue, when the value has to be changed to red, that's the method which is going to be called. And then something which is not in the specification, but that you will see quite often, usually we declare a random method. We're supposed to declare our markup first in the constructor and then to redeclare it in the attribute change callback method in order to be able to update the component relatively to changes which have been made to the attribute's value. So instead of duplicating code, which is something we are not very fond of, we are going to declare a random method in which we are going to put the markup so that we are just going to call this method. And once you have done that, you're simply going to declare your component in the custom element registry by calling the define method. And you're going to pass it two arguments. The first one is the tag you would like to use for your component. The second one is the name of your JavaScript class. Once you've done that, you're ready to use your web component. So in your HTML page, you're going to declare, to import your component because you need your HTML page to be aware of the existence of your web component. And then you're going to declare it like you would do for any other HTML component. And well, I guess you have in your daily life to support old versions of browsers and Internet Explorer and all that kind of stuff. So you will probably need what's called a polyfill. This one is supposed to be the most reliable, stable at the moment, but the good news is, since October last year, Firefox is supporting the full specifications of web components. So every modern web browsers are supporting fully web components. Not Edge, but the thing is, Edge is supposed to move to the Chromium engine. So I guess it will solve it at the same time. So now, how do you move your existing application into a web component? So here, if we look at the manager example, so that's the main JavaScript class of the manager. And so if you're familiar with AngularJS, you should, it should sound familiar. So we're going to declare a component called data manager, which extends HTML element. And in the markup, in the random method, we're going to declare a div. And this div is going to take as attribute the ng-app and the ng-controller of our application. And in this precise case, as we were needed to pass information to a subdirective, we are just declaring the subdirective too, and we're done. With the Angular application, it's even more simple. So that's the main JavaScript part of the governance application. So just the same, we're going to declare a component, we're going to extend HTML element, and instead of declaring a div, we are directly going to declare the top-level component. So very straightforward. So once those two steps are done, that's all for existing applications. We can focus on the new Saagie-Layout, the top-level application. We are going to, in its main HTML page, first import our component, so the data manager and the data governance we just created. We're going to import the design system library. And then we're going to declare our main component, the one which is going to rule them all. And so this component will be the one in charge of displaying and updating every component's, every menu and the main application. So in its random method, it's going to declare the top bar we've seen previously, the top bar, the primary nav, the account menu, etc. And to know which application it has to display, it's going to call the getPage method. And the getPage method is going to look at the path the user requested, and in function of the path, is going to send back either the data manager component or the data governance component. And well, that's pretty all of it for Saagie-Layout. For the rest, it's a very simple JavaScript application with some gulp and a Babel, and that's it. So there were several benefits to this approach. First of them, it provided a very consistent user experience, because no matter if you were on the manager or on the governance, all the menus were looking exactly the same as they were handled by the Saagie-Layout application. Plus, we would have, I mean, we didn't have the use case, but we would have been able to display several components on the same page if we wanted to. And we were completely independent on the deployment side, because the lifecycle of layout was completely separated from the lifecycle of governance and manager. So that was pretty good, but we didn't include other applications in this try because we quickly ran into several issues that were blocking for us. So first of all, it's not a true single-page application at all, meaning that when you were changing application, it reloads the entire page. Plus, it has terrible performances. The reason is we were not simply unbinding and binding components. We were unbinding and binding entire application bundled into web components, and that make a big difference, because those applications were coming with their own version of Babel and their own version of the Saagie-ui library, etc., which first can cause conflict, and which was the reason of those bad performances. So it could have been a true single SPA if we put the time and effort into binding and unbinding those libraries properly, but it didn't worth it because we were having several issues, other issues in parallel. So the problem is we were having a very high dependencies on libraries between apps if we wanted to avoid those conflicts. And so other issues we were having, routers management. Those two existing applications were coming with their own router based on hash. So to stay in a consistent state, the layout, the top level application, has to know about every possible state, every possible path of the two under applications. So we were introducing a very strong coupling there, which we were not really fond of. And last but not least, to be fully tested, it implies to run the entire stack on your laptop, which is neither something you really wanted to do, considering the size of those applications, nor something you can do, actually, because, for example, in the security stack, we were using FreeIPA, and FreeIPA does not run on OS X. So, considering this, we keep layout for the two existing applications, and we decided to move to something different for the new ones. So this second try was called Galaxy, which is basically the same architecture as the first try, except that this time it's based on React Fragment. So here, as you are in an overall application, you don't have the primary nav menu, but it's still there. So we're keeping our components, but this time they are going to be React Fragments. And in the second time, the idea was to use Tailor to stream them, because you can have little performances issue when you're going to stream components provided by different applications. So Tailor would have helped us to fix that. I will not spend a lot of time on this approach, as on the architectural point of view, it's very similar. This way, the benefits we were having would be the possibility to share components between applications. So it means that the design system would have share entire components, like, I don't know, buttons, menu, that kind of things, instead of only styles and behaviors. So that was a big benefit. And we were planning to have a centralized routing system, which means that Galaxy, the top-level application, would have known only the beginning of the path, and sub-applications would have been in charge of the rest of the path, but we were decoupling those applications. And we stopped the try after the first integration, which was security, because we quickly ran into other issues. So we were still having these high dependencies on libraries between apps, about Babel, about the design system, etc. But even worse, we were having the same between React's version. So for example, if security wanted to use a React component which was not in the React version of Galaxy, we needed to update the version of React in Galaxy, but also in possibly every other sub-applications in order to let security to use this component, which was not really what we were looking for. So we stopped after the first integration and moved to the first try. And for the third try, we decided to reverse the logic. So we moved the layout from an application to a library. So this time we kept our web components. They were absolutely perfect, so we kept them. I kept them, and we put them in a very lightweight and pure JavaScript library that we released on NPM. And so existing applications were going to work exactly the same as they do, except that now they're going to install this new library through NPM. So if we are going back on the application side, so here it's the main HTML page of governance. So you can see the component we've been encapsulated into our web component layer. This time, we're going to encapsulate it with a component called Saagie-Layout, which is hidden by default. And that's all that we need to do on the HTML page. Now, in the main TypeScript page, we're going to look at the path to determine if we are in legacy mode or not. And if we are not, we are going to do two things. First, we're going to call the init method on the load layout data class, passing it proper parameters. So here it's governance, the name of the application, and the platform we are currently on. And we're going to call our Saagie-Layout component through the DOM and ask him to become visible. And on the application side, that's all. That's all it takes to modify the existing application. So now let's move to the library side. On the library side, the main JavaScript page is very, very simple. So it's going to import its components, its web components. And it's going to export the load layout data class we just called in the governance. And that's it. And this load layout data class is going to be in charge of making every API calls needed to configure properly the menus in function of the user rights and profile. And that's all it's going to do. It's not going to modify the rendering, it's just going to make API calls. So we are retrieving, once again, the Saagie-Layout component, and then we are calling the load data method. And the load data method knows, okay, so I need to have rights, and I need to have the profile, and I need to have jobs data. Great. And each method is going to give us back some part of the profile of the users. So for example, the load right methods is going to send us back the list of platforms the user is allowed to see. And then we're going to call the set platforms method. And that set platforms method is going to update the attribute value of the component. So here it's the platform list object attribute with the new list of platforms. And as we've seen previously, you should know now what's called when the set attribute method is called. So in the layout class, the top level component, which is a web component, this call is going to trigger the attribute change callback method. The attribute change callback method is going to look at the attribute which has been updated, and in function of that attribute, that's the class which is going to modify the rendering of every sub-component. And that's the only one who is doing this, which is doing this. So here, for example, okay, the current tab has been changed, so perhaps the user has moved from the governance application to the security application. So I need to remove the highlight from the primary nav and put the highlight on the top bar. And maybe you noticed that the layout class has no render method. Instead, it has an init render method. Even if the markup looks very, very similar to the one we've seen in the first try. And it's true that it's almost exactly the same, except that this inner HTML you're seeing there actually is our existing governance application. That's the data governance tag we encapsulated. So that's the reason why we call this method initRender, because we wanted to be sure that there is no way it can be accidentally called 2 times. For the very same reasons, we, before registering the custom element into the custom element registry, we're going to check if it has not already been declared. So, it's absolutely not a single page application anymore. And with this approach, we are not able to display several components on the same page, which actually is not a problem at all. The real problem was that we were not in the good use case for the first two tries I showed you. The thing is, we were not making an aggregation of components. There were no business cases where it would have sense to display governance part with manager part. We were much more doing an aggregation of single-page application than an aggregation of components. And that's the moment where we are talking about page transitions. So there is two types of page transitions. Soft navigation, which is what's happening when you're moving from a page owned by a team, which belongs to one application, to a page owned by another team, which belongs to the same application. So for example, when I'm moving from dataset to domains in governance, that's soft navigation. And in this case, the framework, Angular, will handle that for me. So it will unbind and then bind components without reloading the entire page. And that will be completely transparent for the users. Hard navigation, at the opposite, is what's happening when you're moving to a page owned by a team related to an application, to a page owned by another team related to another application. So for example, when I'm moving from the manager application to the governance application, that's hard navigation. And in this case, I can hardly avoid to reload the entire page. And that's the main case for Data Fabric. So, okay, not a single page application at all, and no aggregation of components, but that's fine. And that's even better because obviously displaying a single library is way more faster than unbinding and binding a component encapsulated into a web component, an application encapsulated into a web component into another application. Plus, this solution is easier to integrate, I think, all included, and I mean Q&A test and code review, etc. It took me 1.5 days to put it in production, I would say. But it's true that this approach may result in a slightly inconsistent user experience. If, for example, the Layout-as-Lib team has released a new version of the library, which includes a new menu item in the primary nav, for example, new application intern. Whoa. Until the moment on the governance application, integrate this new version of the library, this new menu item is not present on the governance part. And perhaps manager on its side has already integrated it. So, for example, if the user is on manager and now it's moving to the governance application, the menu item will not be present anymore. So slightly incoherent. But we decided that it was worth it, because the thing is, with this approach, we are completely independent both on the deployment side and on the development side. If this new menu item is coming with a bug, some things that happen, you know, it has no impact on governance. I haven't updated, so I'm just going to wait, you know, for the next patched version of the library, and I'm fine. Everything is going to work properly until then. And for manager, it's not a problem neither, because they just have to, you know, roll back to the previous version without the bug and wait for the patched one. So everything's fine on this side. But it's true that in case of breaking changes, it implies to redeploy the entire stack, which actually is an npm update. So it has happened to us, and in less than 1 day, it was solved. Every applications were updated. Plus, we solved the libraries conflict, because now, you know, instead, when I need to update to the next version of the Layout-as-Lib library, I'm just going to look at which version of Saagie-ui the new version is using. I'm going to update the version on governance, and then I'm going to update my version of the library, and no conflicts. Plus, and I think you understood it was quite a big thing for us, this version can be completely run on its own. You don't need to have the entire stack running on your laptop to test it. What we used to do is to have several Express servers, very little Express servers, which were mocking all the API calls, which were made by the load layout data class. So you know the get rights, get profile, get jobs data. You're just mocking that, you're running them locally, and you can fully test your solution. So this approach works pretty well for us. In 1 year, we've been able to deliver 4 new applications, and we've been able to broke the manager by first extracting the security part into its own application, and to start refactoring it while it was still living on its side, by starting a new project called Project and Jobs. Some best practices before we finish. Think about your use case first. I hope you understood that that's really the main part you have to think about before going for micro-frontend. Are you going to do an aggregation of components, or are you going to do an aggregation of single-page applications? In other terms, are you going to have soft navigation or hard navigation? Take care of your design. This one is very important too. So you can think about design system, but you can also think about other solutions like optimistic UI, which is nor a framework, nor an architecture, etc. It's just taking the approach that in most cases, all API requests will be responded positively. They will have a positive answer, you will retrieve the data, or the action will be saved, etc. So you're going to send to the user positive feedback as soon as possible, and simply roll back in case it hasn't gone well. So that is especially useful when you're having an autosave, display. So you need to provide feedback to your users if you're not going to provide them a save button. So in this case, go for optimistic UI. Skeletons on the same way, neither a framework, neither an architecture. Skeletons, actually, you already have skeletons on applications you're using in your day-to-day life. Slack, Twitter, Gmail, LinkedIn, Spotify, etc., etc. Skeletons is, these little shadows you're seeing when the application is loading, so that it gives you a guess of what the application will look like. It's very important. It's not expensive to implement, and it's very important because it gives the user the message that something is happening. It's just not, the application has not crashed. It's loading. Data are not there. The data is not there at the moment, but it's going to arrive in a few moments. And very important to share resources, not your runtime. Even if you're going to use the same framework all over your stack, like we did with React, don't share your runtime. But do feel free to share resources, like, for example, I don't know, fonts, icon, images, even API calls that could be shared. Just don't touch about the runtime. Don't touch at the runtime. So if you want to go further, here are some links you can find useful. Microfrontends.org is the website on which the first try is based. So the website is already full of information, but it's also joined by a GitHub, which has 2 examples. One with custom elements only, and one with server-side includes. And server-side includes is definitely something you want to have a look at if you're going to aggregate components and to display them coming from different applications. Michael Gies, who is the author of microfrontends.org, gave an excellent talk at Web Rebels last year, if you wanted to have a look at. Experiences using microfrontends at IKEA, so it's a technical article on InfoQ. It's not really technical, it's not giving enough technical details to my test, but it's completely understandable because it's kind of their secret recipe. Still very interesting to have a look at the way they have done that at IKEA. Project Mosaic, so it's a set of library and resources to aggregate fragments. It's open sourced by Zalando. Taylor, which I told you about previously, is probably the most famous amongst those set of libraries. And single SPA, it's a light JavaScript framework to aggregate light single-page application. That's the reason why we didn't go for it, because it looked to be really made for light single-page application, which was not our use case. That's all for me. We got 5 minutes left if you have questions. Yeah.
In a human point of view, how did you change your UI teams, and did you restructure your UI teams? Did they move around? Did you?
Yeah.
From
So
a human point of view,
the UI team is it's a 3-person team, and they are. I wouldn't say isolated, but they are on their own side. They are not integrated to a development team, and they are working with everybody, including the marketing. So they are at some point we introduced a design review. So when we were about to deliver a new component or a new screen or whatever, we were having the code review, and someone from the design team has to check that the design was fine, that everything was supposed to was respecting the chart, and was doing the review. So we were working with the one who was available at the moment. They were isolated, separated. I think we were having another question on the first. Yeah.
Thank you for your presentation. For the first try, you had one library and multiple applications. So we have some consistency in version in the library.
Mm-hmm.
But in the third try, you have multiple versions of the library. Was it hard to manage the versioning of those libraries? Because you had 3 versions of the same library in the 3 applications.
Yeah, well, it's not really, because we were not a big team. We were 10 developers, something like that. So it's not really a problem. Every time a new version of the library was released, we all know about, and we simply upgrade very soon, and that's it. I guess if you're thinking, for example, of the use case of a company like IKEA, which is way much bigger, that would be more difficult to handle. Probably you will end up with very different versions of libraries used across all the applications. Yeah, hopefully in this case it was pretty easy. 10 people, so yeah. Yeah.
At the end, you do npm build and you host it, for example, on NGX.
Yeah.
And how does it, from performance standpoint, if your one library is mostly used, how does it affect on some other ones?
You mean on other ones? Which one are you thinking about?
For example, the Galaxy is mostly used, and if it takes all the load, and how does it behave some other library that's also
Oh, you're talking about the sub-applications, right? Well, we didn't have the problem actually, because Galaxy has not been in production very long, as it has been replaced by the third try. But we were having a lot of load balances and reduction, etc. And we were on Kubernetes, so we can auto-scale, quite easily. So can't really think about another way to manage that. But the goal it was, because definitely the first try, Layout was taking too much resources, which was already better with the second try, but definitely the third approach is the most efficient when you're having entire applications running on there.
Okay, thank you.
One quick question about the fact that you can use this time different versions of the libraries, which is cool. You can continue to develop at your own pace. Does this normally should mean that your browser should download much more versions of the libraries as well, because you are loading these components. So this technically should affect the size of the web application in the end for the user, that it has to download all these components the moment it navigates in the page. Because if you are going from data management or from management to data sources or whatever, and you have to load security. If everybody will come with another version of React or another version of Vue, your browser will have to download this another version for your component to work. Was this a actual burden or penalty from user perspective?
So something I didn't detail here is that when we started working on the version 2, we decided to have the same stack all over applications. So we decided to move every front-end applications into React and every back-end applications into Kotlin. And the reason why we made this choice is because as we were a very small team, we wanted people to be able to change to move on another application in function of the roadmap emergencies. So that's a very good question. We didn't have the issue because everything was in React, except governance, because it was an existing, already big application, so we didn't have time to refactor it. But yeah, that's true that if you're having complete different frameworks, it could take a little bit more time. But well, still, I think the third approach would be better in this case, because the library has been thinking to be as lightweight as possible, very, very simple, pure JavaScript, so that it's just loading like that. Yeah. Time's up, but I'll be happy to answer any other questions after that. Thank you very much.